So in this lab, we put different substances into different beakers with hot water, and then we stirred the substances into the water, and then we placed the mixture or the solution into a petri dish, and then we let it cool overnight so we can form crystals of alum, borax, copper sulfate, and table salt. After about a weekend of letting them evaporate and form, we came back and observed the crystals on Monday. And for alum, our group found that the crystal type was cubic. For borax, we found that it was monoclinic. For copper sulfate, we found that it was orthorhombic. And for table salt, we found that it was cubic as well. So a crystal lattice is a repeated 3D structure or a pattern that ions are arranged into to make an ionic compound. And based off these crystal lattices, we can tell how the anions and the cations in each ionic compound fit together to arrange the structure, and then it also helps show the strength of the crystals. And the recrystallization process is also present in this lab because the solute is dissolved into a pure solvent, and then that helps get rid of the impurities in the solute, which then leaves the ionic compound and the crystal remain to form over the weekend. Overall, for our group, the hardest crystal to identify was the alum, because for our group, the alum was very spread out and kind of the crystals weren't very prevalent. They were kind of just like, it kind of looked like it was like salt and water and kind of like looked swirly. So it was really really tough to tell what kind of shape it was and then how strong it was. But the easiest was table salt because each crystal was like a square block, and they were almost like in perfect line together. So those were the hardest and the easiest. And then as far as the rate of evaporation goes, the slower the rate of evaporation is, the larger the crystals are, because the crystals are more pure, so they grow more steadily because they have more time to grow and they have more time to form the way they're supposed to. But when it's faster, they become smaller because they're now impure crystals, and then they bind to a crystal lattice, and then they end up getting trapped in the crystal lattice that they're not supposed to be in. As far as errors go, our group did end up boiling the water a little bit, like it says not to in the procedure. And then as well, our group also left the covers of the petri dish on over the weekend, so it may have not evaporated the way it was supposed to because it was sitting for way too long. But yeah, the crystals still formed, but they may not have been like they were supposed to.